Okay, so today I'm going to demonstrate to you how we would perform a differential extraction using a combination of the QIAcube plus the EZ1. So if you take a look in your lab notebooks, on page 55, we have a pre-treatment or a digestion that we need to do of our swab samples. So if you remember, for this, our first digestion that we're interested in doing is to digest those epithelial cells, but we do not want to digest the sperm that is on the swabs. So if we take a look at the samples that we have 2 sexual assault swabs that were in our sexual assault kit, here and here. First thing I'm going to do is I'm going to bleach and ethanol down my surface. Ethanol. So if I were in a crime lab and I had 2 swabs from my sexual assault kit, I wouldn't want to consume the entire swab. So what I would do is I would use a scalpel to take about a quarter of the swab and retain the rest. So here we have our swab. I am going to do my best to take about a quarter to half of the swab. That's a little bit more like a half. These have already been sterilized. I'm going to take my elution tubes for the QIAcube and put that in. I will label the tube what it was called, 20-1. And I will do the same thing. Of course, I am retaining this, as you see. I would then take the next swab. I would change my scalpel, however, I'm not going to do that. And I would take off a quarter of the swab. Again, the 1.5 QIAcube elution tube, clean forceps into tube. Label. Done. Okay, so the next thing I have to do is add in the ATL buffer and add in the proteinase K. So this will start the lysis of our epithelial cells. So our protocol calls for 500 microliters of buffer ATL. So we will add that to each sample. Sometimes this buffer ATL gets some kind of, not particulates, but sometimes the buffer itself will harden a little bit, and you will have to heat it up to kind of dissolve some of that. The next thing that our protocol calls for is 20 microliters of proteinase K. Okay, done. Now we will put our 2 samples on the thermomixer at 56 degrees Celsius for an hour and a half at 900 RPMs. Temperature 900. And we're off. So now our samples are done. We're gonna take them off the thermomixer and we are going to take them over to our mini centrifuge and just spin down anything, any droplets that are on the top of the lid. Okay. Now we will need to use a spin basket to remove any liquid that is on the swab. Again, these would be sterile forceps. We would fish out our 1/4 to 1/2 of swab, put it in our spin basket, insert the spin basket back into the tube, and then repeat for our second sample. Again, cleaning these in between samples. Now we'll take it over to the big centrifuge and spin it down for a couple of minutes. Typically this would be done at full speed. And starting. Okay, so now we are removing our 2 samples from the centrifuge. All of the liquid should be removed. And we will take it over to the QIAcube. So it's very important to always consult these QIAcube protocol sheets if you are ever unsure what you need to do. These protocol sheets tell you kind of exactly what's happening. So for this one, we are going to be looking at our epithelial and sperm cells, and this is going to do a separation and a lysis. It tells you kind of what kind of adapters and vessels you need in the QIAcube, so I'll show you how we need to change some things in our QIAcube to get that done. It tells you what needs to go into the rotor adapter. So the first thing I will do is I'm going to remove the spin basket. We don't need that anymore. And remove the second spin basket. I need to find some rotor adapters, which we actually need to open up. Okay. So we've got our rotor adapters. We have our trays. We consult our book and we see that in position 3, which is, remember, you hold this by looking for things like the 1 notch, this notch right here. This notch right there is actually bigger than that notch. So this one is where we want to put our sample that contains our lysed epithelial cells. It should also have sperm cells in there as well, however they are unlysed. So that is all set up. Here's a closer view of that rotor adapter. So that tube that says labeled SF tube is our tube that contains the lysed epithelial cells and the sperm cells in there. Tells us that we need 1,000 microliter wide bore tips. We need to put on a different shaker adapter, one called S2, and we need screw cap tubes in the kind of lysate portion, and the reagent that we need to put in position 1 is reagent G2. So all that's going on in this separation step is merely performing a separation between the epithelial and sperm cells. So we're not doing any purification at this point. We are only doing separation. So I will change the base to that S2 base. Okay, here is our different base. This is basically going to accommodate the different tubes that we are going to be putting in. Take that out. It told us that we needed wide bore tips. So let me see if we have any in here. These all look like the normal ones. Here we go. The reason why we need the wide bore tips is actually because if we use the normal tips, the sperm cells could not travel through them, so they wouldn't be picked up when they needed to be. So we're going to load up our wide bore tips. We are going to load in our samples. I will consult the manual again so we see how we need our 2 samples. They'll be in positions 1 and position 7. So remember, this is only going to go in one way. So if you mess up, it doesn't matter. Now we will be putting in our G2, which we should have some. Here we go, our G2. position 1. It tells us that we need to have 2 milliliter screw caps. So these are different. They don't have an actual lid on them. So there will be one thing that we have to do different on here. So if you remember before with the 2 mil tubes that had the lid on it, the lid kind of hooks into here. So for the instrument to recognize that, hey, I have 2 samples loaded here, we need to kind of tell it where those 2 samples are at. So we should be good to go. Basically what is going to happen here is we are going to end up with our non-sperm fraction is going to be in this in these tubes, in these 2 mil tubes, while the sperm fraction is going to stay in the 1.5 mil tube. The G2 is going to help further digest. So what we would do is we would go back to our, take you back to our initial and we have epithelial cells lysed in these 2 tubes. If we can get it out. It should not be this hard. There we go. Okay, need to make sure you don't mess up which is which. And now actually we can do something with these 2 as well. We should have now separated the sperm and the epithelial cells from each other. So actually what a lot of labs might do in this scenario would be that they would take a small portion of their separated sperm fraction, what I've been told, it's usually about 3 microliters, and they would put that onto a, they'd put that onto a slide, and then they would do our Christmas tree staining. If you remember what we did on the very first lab. We'll go ahead and label these real quick. This is our 20.1 and this is our 20.2. So the first thing we would do is we're going to want to fix the sperm heads onto this slide, and the best way to do this is to use a heat block. So we will do just that. Basically, we will wait for the liquid to dissolve all the way, and then we will proceed forward with our Christmas tree staining. Okay, so after the QIAcube separated the sperm from the epithelial fraction, I just showed you how we are going to confirm that there is sperm in the sperm fraction, but we still need to process our epithelial fraction. So I want to make sure label stuff. But we'll take a look at our QIAcube protocol, and it's going to tell us for the non-sperm fraction that we are going to add 400 microliters of buffer MTL to our sample and then place it directly on the EZ1. So buffer MTL is a lysosin binding buffer from QIAgen. It's been known to kind of help with recovery. It's especially good with kind of low amounts of DNA. Okay, so we're going to add 400 to each sample. Okay. All right, now we are going to put it on the EZ1 and run DNA purification large volume protocol. So the EZ1, just like its name sounds, is actually a very easy instrument to run. This does all of our automated extractions. So let me go through and show you what we would do. Oops. Okay, so what we would do is we'd want to see, or we'd want to tell it which protocol to use. So menu options kind of confusing, but basically we want to do a run, so we would press start. It takes a couple seconds before it gets to the menu. Do we want to create a report file? No, we do not. Now it says which protocol should we do. The protocol that we're doing is the large volume, so we select 3. We will go ahead and elute in TE. We will pick 50 microliters as our elution buffer. It goes through and it tells you what you've chosen, which is nice. You can always go back and choose something else. Now it tells you to load the cartridges at the same position as samples. So cartridges go in this thing here. We can run up to 14 samples at one time. So the cool thing about these cartridges is that it contains basically all of the same buffers that you all used in your normal extractions, but just all in here. And inside we can't really see, but there is something that is going to puncture these and function as a pipette. Also, these black beads are magnetic beads. These work just like our silica. Membranes, except they are beads that are magnetic and contain those silica membranes. They will bind the DNA initially, and then we can go through and do our washes and then our elutions. So we'll basically just slide these cartridges in. Now we're only processing 2 samples, so we only need 2 cartridges. And we will put that in. There we go. We can go ahead and press enter and it'll tell us what we need. So into the first row, we need elution tubes. So I will go ahead and grab some EZ1 elution tubes. Elution tubes are typically these 1.5s. And again, we want to make sure we have everything labeled. So this is our 20.1 and this is our epi fraction, and this is our 20.2, and this is our sperm fraction. So you take the lids off, put them in positions 1 and 2. Now let's see what it tells us to do. Load the tip holders and tips into the second row. Here are our disposable tips. These are the tip holders. And these, as you can tell, are the filtered tips. We skip row 3 and into row 4, we add in our 2 mil tubes plus the MTL buffer. So those will go right there. And then we will load this up. We will shut the door. You will enter, and then you will press start, and then our extraction will be on its way. So while our female fraction is being purified, we still need to actually lyse our sperm fraction. So somebody else is confirming that sperm is present. So let's go ahead and set up the QIAcube to get the sperm heads lysed and washed. So we will consult this protocol, separation and lysis 12B. Again, this could do 12 total samples, but we're only doing 2. So we have our same 1.5 mil tube from part A that's still in the rotor. We are still going to use G2 in our position 1. We're still dealing with sperm cells, so we still need the wide bore tips. If we turn the page, there's something different that we need to add. So you all should remember that in order for sperm to lyse, we need to add our friend DTT. So we will add a kind of separate buffer that is a mixture of G2, proteinase K, and DTT. Now it tells you how much of G2, proteinase K, and DTT that you need. So let me get a little tube for us to use. Okay, so we need 265.5 milliliters of G2. Okay, here's our G2. Here's our pipette. 265. Okay. That is good. Okay. And then we need to add 17.7 microliters of proteinase K. We do not have the correct pipette here, so I will just do 2 aliquots of it. I will do 10 and a 7.7. Seven point seven. Okay, now the most important ingredient, 70.8 microliters of DTT. So we do have the right pipette here. $70.8. add that to the tube. Okay, so now we have our mixture of our DTT, Pro-K, and G2. So in this protocol, actually no samples tubes are necessary. We're not separating anything out. We're not purifying. All we're going to do is we're basically going to be washing the sperm pellet. So, and we're going to be basically kind of starting lysis. So this mixture that we made is going to go into position A. We have G2 still here. We don't need this because there is no sample tube being used. And we are able to merely put our samples right back. Just to confirm that this is what we are doing. Yep, okay. So we can shut the door. We'll do DNA, pipetting, select, sperm and epithelial, 12B. Start, it's going to take us through. It's going to say that we have our sperm cells in one 1.5 milliliter collection tube, which we do. We're emptied the waste drawer already. We refilled our tip racks. In position 1, we have our G2 alone. And then in position A, which was that small little position, we have our mixture of G2, Pro-K, and DTT. And then now we can press start. And then it'll go through and do all of its checks. Okay, so our sperms are being washed and lysed on the QIAcube, and our female fraction has finished purifying. This protocol only takes about 14 minutes. So now we are going to unload the EZ1. So usually I go ahead and take the entire thing out. We have our elution tubes in front. Now they have liquid in them. I noticed that I accidentally labeled this a sperm fraction, but it is also the epithelial fraction, so you can ignore that. Now we're actually able to throw away these, and we do not need the lysate tubes anymore either. The cartridges have been used, so you can see how they have been pierced. Again, we can throw those away. Put those back on. And then it is advisable to now run this through a UV setting to remove any kind of exogenous DNA that is present. Okay, so our sperm fraction is done. Now, what has actually happened is the QIAcube first went through and it washed the sperm pellet to remove any epithelial cells. And then what it did is it took a pipette and it pipetted our mixture of G2, Pro-K, and DTT directly into this 1.5 milliliter tube. But because it couldn't then take this tube and transfer it to another tube here to do the shaking lysis, we need to basically finish up the lysis on our own. So we will take our 2 tubes, and we are just going to do the quick lysis today, which calls for us to vortex and incubate at 70 degrees Celsius for 10 minutes, shaking at 900. So I can quickly do the vortexing, and then I will move on to the thermo shaker. Raise the temperature. only need to do for 10 minutes. Alternately, you can do at 56, shaking overnight. So we'll let that go. Okay, so now our quick sperm lysis is done. So all of these sperm heads should be completely lysed, and because we did a wash step in the QIAcube, it should be generally free of epithelial cells. So I did not add MTL to this sample. So because I didn't add MTL, basically now I will do what the QIAcube calls the trace protocol. So we'll do the same thing. We will go through the menu and then get to the protocol that we want. No. We will do the trace protocol. So basically the only difference between the trace protocol and the large volume protocol is that the large volume protocol has a larger amount of initial lysate, whereas the trace protocol has less lysate, basically doesn't contain that MTL. We'll go ahead and do TE, and I like to keep with 50. Again, it tells you what we've chosen, so we can hit next, and we will do the same thing. We'll take the sample tray out, take this out, we'll load these guys up. So the cool thing about these tubes is we can actually just cut the cap off of these tubes and run them directly on the EZ1. Again, you're gonna make sure you know which is which. Okay, so my battery died, but basically what we had done is we were loading up our lysates onto row 4. You should remember that from before. We can then load in our tube, our tips and our tip holders into row 2. And then we have our elution tubes, which is where the purified DNA from the sperm should come out. This is where we will label our tube, the sample number, plus the sperm fraction. I will do just like before. We're going to put this guy on, then we are going to load this up. Next, next, next. Close the door, and then we press start, and then our sperm will be eluted. I'm not going to show you the taking off of our samples, but stay tuned. I will take us through the quantitation and the STR process as well.